Hello and welcome back. Yesterday I built this RF sampler, a 3-in-1, because it also has a dummy load and it also has an extra exit for a frequency counter, and it has a variable and a fixed output, sample output. Um, I got a really nice comments. Thank you for that. Everyone, well, most of you liked the build. The design was not mine. I just took it from the internet, and they are just the most common schematics for the samplers. So, but I didn't have one, so I just wanted to make it. Yeah, one of the comments was. How flat is it? So I need a spectrum analyzer for that. So let me try that. My frequency counter with the tracking generator is the little USB one, this one, but it starts at 35 megahertz. So it is a bit of an issue to measure below, but I will try. Then I have here my another spectrum analyzer. That's my Aritu. It goes from 9K up to 2 gigahertz. So that could be an option, but it doesn't have a tracking generator. Usually for that I use my noise source, but the noise source is also not flat, so that is another thing. So maybe I was thinking later I can use my nano VNA, because the nano VNA also has a sort of a tracking generator output to measure filters. So that could be an option. But let's play a bit first with the radio. I have here an CB radio. Yeah, it is it's a cool one. Not only does it go a lot of frequencies, but the power is very easy to adjust. So I can adjust from 1 watts, I think, up to almost 40. So that is cool. So what I want to measure first, just start simple. Put the power in, put the power out. Do I still have 10 watts, or is my straight through broken? Then I'm gonna measure if the dummy load works. Someone else already said, it's fun, all your labels look very good, but I think it's thermal labels. So let's see if all my labels turn out ugly brown because of the heat. I didn't think of that. So I'm just gonna play. First, I'm gonna connect the transmitter directly to the Marconi, adjust it exactly to 10 watts. Then let the power go through and see if we still have 10 watts, so we don't lose all the power, which of course we should not. And then I can put it to the dummy load, see if it gets very hot or not. And if it doesn't, then I can measure with the Marconi on my 40 dB output if I indeed, my 10 watts goes all the way down to 1 milliwatt. Okay, I put now the camera on the other side because maybe it's better to see, and maybe later I can zoom in into the Marconi. I'm gonna connect first on the Marconi directly to the CB radio and adjust it to 10 watts power. Transmit test. I'm doing nothing yet with the sampler. The sampler is just here. Let me just connect that. Power supply switched on. Power to the lowest. Let's have a look. 0.8 watts. I think I need to zoom in. Okay, running. Transmit. Let's adjust to 10 watts. Okay. Right. Now we're going to put the box in between, and let's see what we have then. First I need my cables. Put this away. I have here. Get the BNC I have here. Edit output, edit output. And we put the, now we're going to go to the input, into the computer. We use 1 watt. Okay. Yeah. The center pin of these BNC connectors, these pins here are in my cables are very tiny. So there was not a good contact. I fixed that with the screwdriver. I push a little bit the pins, so that works better now. And if I measure now, we have around 10 watts, 9.7. And what I want to do, I can have here my 40 dB output and put that on my other input of the Marconi, which measures the lower. And when I transmit then, oh look, also almost 1 milliwatt. So that is indeed 40 dB. Cool. So if maybe I can put a little bit more, exactly 10, switch over. Yeah. It's almost 40. 1 milliwatt. 10 watts. Ah, cool. That works. What does the variable do? So I'm now using the internal dummy load of the Marconi, so I didn't switch over, but I can do that. If I switch this one to the dummy load, then you will see the Marconi should not have anything here, but this port should still work also for the same 1 milliwatt, and it does. And surprisingly, the box doesn't get that hot, so it's 10 watts is nothing for this 1 watt resistor. Yeah, now it slowly starts to, the screws are getting hot in the bottom here. But cool. Okay, this is the fix. That is exactly 1 milliwatt. And if we take the variable one, it is just a little bit less than a milliwatt when the box is closed, and when it's open, it's a little bit more. A little bit more, and so it's now 0.8, and now it goes only more to 40 milliwatts. So if you have a transmitter with a bit lower power, with this one you can do less than the 40 dB. So that is nice. Now let's also see how much signal is for the spectrum analyzer. First I check with the oscilloscope. This is to see if it's not too many millivolts. No, it doesn't detect anything. Here it is. It is 13 millivolts top. That's very low. I hope it's enough, because usually the frequency counter needs, well, I'm always testing with 50 millivolts. I'm not sure. Can you see that? Yes, you can. Okay, there was not enough signal, so I just bent a little bit this little antenna here. And then at 10 watts, I have now 30 millivolts, which should be enough for a frequency counter. So if I now put this in my frequency counter, yes, there it is. Perfect. That works. So now I put it on full power. That is well, that is about 33, 34 watts. If I switch over on the 40 dB, that is indeed 3.4. If I look now at the oscilloscope, this is 45 millivolts. So that will probably be around 100 millivolts, maybe, if I do 100 watts. But that is perfectly manageable for a frequency counter also. So I'm not scared to put it in, and there it is. No problem. Okay, that works very well. Everything is now getting very hot on full power. I like to see what the dummy load does. Now you see it's a little bit off. Instead of just 27,965, it's 964,9637. So it's a little bit off, but it's okay. Put a little bit less power, put it back to 10. 10 watts. I'm just trying now the dummy load, but it is really for super short usage because it becomes very hot. I'm now on 35 watts. 1, 2, 3, 4, 5. And now I cannot hold it, so that is already 60 degrees then. So, yeah, the dummy load works fine, I think, for a few seconds. The idea was nice, so you can switch it off also. And now on the lower power, it's no problem. So if I go back to 10 watts, that would be 1 milliwatt here. But it cools down very quickly. So the dissipation is good because when I stop transmitting, it immediately cools down. So that works well, the whole box. And I'm just feeling it in on the screws. So if I do 10 watts, yeah, I can just keep transmitting. It doesn't really get super hot. Still transmitting. Still going, still going. Yeah, I can still hold it. So you can do 30 seconds to a minute. That doesn't matter on 10 watts. So for low power, this is perfect. Perfect solution. Yeah, now it starts to go up. I think we are almost to 40 to 50 seconds. I can still hold it. Yeah, no problem here. Now it's getting hot. So I think you can do a minute with low power. 10 watts. So, well, I have the spectrum analyzer here. I'm just gonna do a check if it all works. Single shot, and I will show you the screen later. Well, as you could see, that was reasonably flat. So that was just a short. So I'm gonna do the same here with the RF in. RF in. That would be the tracking. So RF out. Then I take the normal output first, and then we normalize that. So output, and that one goes here in the RF in, and I'm gonna do the same. I do a single shot, and I show you the picture again. Single shot, here it goes, and up till 1500 megahertz. Now you see it go down 2.5, 3, and then 4, it goes up. So this is only measuring. Well, I think I'm not going to normalize it because as you could see, it only starts to drop after 1500 megahertz, and I'm not going to use it that high. And of course, then we're going to deal with a lot of other stuff. So I'm not going to do that. So now I'm going to go, let's say we just check until a gigahertz. So I will change that. And then instead of the full output in, I will start to use the 40 output, and I will put it to the dummy load and see what happens. Well, the fixed output is reasonably flat. We see a little extra attenuation here around the 300, and then above 500 you see we get less and less and less attenuation. But in the lower part it's reasonably flat. I wonder what this thing is. Now I open the cover and you see it, this is even more, and the rest is more or less the same. So we really need to close the box. Yeah, and if we don't use the internal dummy load, so it's just open, then it becomes a mess. And this is exactly why you need to use a dummy load. Always properly terminate, and I will zoom in on that. Now I did another scan, just up to 600 megahertz, and it's actually quite flat. And also the dip seems to be less of a problem. Nice. Now let's try to do the variable one. Just gonna put it to the minimum first, and we're gonna do a scan again. Oh, that is a lot less flat. And here exactly at 300, it's a dip the other way, but here we end up with a -10. So you really need to be careful with this variable one. It starts at 40, and then quickly it goes already higher, and then it goes. So yeah, now I put the pot to full power, and as you can see, it is not that flat. We are now around 20 dB, but if you look up to 400, then it kind of could be sort of flat. But yeah, I just took any coil that I just had, and I mean that ring, and then I just put 12 or 13 rings around it, turns around it. And yeah, I just need to test a lot more with this. But yeah, I like the question. It's cool. Okay, well, I'm gonna do another test. I was thinking to use the Tiny ESA. It's also a little spectrum analyzer. Works actually very cool because it's very sensitive. It just picks up already the radio channels. Very sensitive. I like it. But I have not been able to find it. I'm not a reader. Uh, if it have a tracking generator or how to use that. So I was thinking instead of that, I should be able to use the Nano VNA, and I already run it quickly through the calibration. And let's just see if we can do that. So then my input should be this one, I think. And my output here, I can just first do a short just to show you what happens. I'm gonna switch off for some stuff that I'm not using. Display, trace. Let's not do the purple. Stop. Stop. So back. Well, I switched now off everything, and now it's more or less like a spectrum analyzer. Here you have the zero line. Oh, no, the zero is here, but this is the lowest signal it can receive, and it's now in -100 dB. So if we short it, we should have more or less a line in the top. If we connect well, yes, so this is 0 dB then. So as you can see, it's nicely calibrated. It's now scanning from 50K up to 900 megahertz. And we all have a straight line, so it is calibrated in that sense. So then we, assuming that this is the transmitter, yes it is. This is receiving. Then we put the RF in here. So this is like a tracking generator in a sense. It's a tracking generator output. And here we have the normal input. And also here, you can see it's more or less flat around the, well, 39.75 in the beginning, and we can walk a little bit more. and it stays all around 40. And here it becomes a little bit less. And that is again around 600 megahertz. So below that, it is reasonable flat. Well, then let's see what the variable does. I'll put this one back. And we just change it over. First we put again to the lowest. Yeah, this one is not flat at all. Not at all. And if you put it to maximum output, it gets a little bit better. So really when we try to load the coil, yeah, it is not necessarily good. But I like that the fixed one is flat. So that was it. Well, I was kind of surprised that, well, not really, that the variable wasn't that good because I just picked a ring and it just put some windings. I read that you need to have 12, but I didn't even look at the size. I was just looking what it would be. And but the fixed 40 dB, I can really recommend up to 600 megahertz. It's almost flat, and especially with the lid closed, it is really nice. So thank you for your question, and it was really interesting to see. And yeah, and I guess the other guy was right with my thermal labels because the box is getting really hot. But I don't use it too long. When I feel it's hot, I just stop because indeed my labels will turn brown. Thank you for watching, and I hope to see you next time.